All right, let's just dive right in. Today we're tackling one of the absolute most critical skills you can have in the modern software industry, and that is mastering Git and GitHub. Now, even if you have zero idea what those two words mean right now, don't worry about it. We're going to break it all down from scratch in this explainer, and we're going to use some highly relatable, real-world analogies that are going to make sure this sticks in your memory for a long time.
Because, let's be honest, have you ever been working on a project or writing a piece of code and you accidentally delete a crucial file? Or maybe you try to add a cool new feature and suddenly everything completely breaks, and you're just sitting there desperately wishing for an undo button that rewinds hours of work, not just one keystroke. We have all felt that heart-dropping panic. Well, version control is your ultimate safety net. It's the permanent solution to this very universal problem.
So here's our roadmap for today as we walk chronologically through a developer's day. We'll start with the difference between Git and GitHub, move into the basic workflow, talk about branches and collaborating with teams, look at how to fix merge conflicts, and finally, my favorite, undoing mistakes in Git. Okay, let's kick things off with our first big topic, the difference between the local tool and the global stage. Before we can even define what Git is, we have to understand the concept of a version control system, or VCS. The best way to think about a VCS is to imagine a highly detailed bank account statement. Your bank statement meticulously tracks every single credit, every debit, and the exact timestamp a transaction happened, right? A version control system does the exact same thing, but for your code. It tracks precisely when a file was added, when a line of code was deleted, or when a specific feature was modified. It gives you a complete, flawless history of your entire project.
So, what is the difference between Git and GitHub? Well, Git is the actual version control system itself. It's free software that you install directly on your personal laptop to track your local code history. It's the engine. GitHub, on the other hand, is a global public website. It's the platform where developers upload, store, and manage all that code they've been tracking using Git. So just remember, Git is your local tool and GitHub is the global stage.
And that brings us to repositories, or repos for short. A repo is simply the project folder that Git is currently tracking. But when you upload that repo to GitHub, it becomes something much more powerful. Think of GitHub almost like an Instagram portfolio, but for developers. Just like a model uses an Instagram portfolio to show off their absolute best photos to casting directors, developers upload their code repos to GitHub to showcase their skills to recruiters, HR departments, and really the entire world.
Moving right along, let's look at how this actually plays out when you sit down to write some code. When you're typing away in your code editor, Git is constantly categorizing your files behind the scenes into very specific statuses. If you create a brand new file, it's untracked. Basically, Git has no idea it exists yet. If you edit a file you've worked on before, its status becomes modified. Once you tell Git, hey, I want to save these changes, the file becomes staged. And finally, once those changes are locked into your history, the file is considered unmodified. This is pretty much your mental cheat sheet for what Git is thinking at any given moment.
Now, to actually move your files through those statuses, we use a really simple two-step process. And honestly, it's incredibly easy to remember if you just think about real-life relationships. Step 1 is the command git add. This takes your modified code and moves it to the staging area. Think of this as the engagement phase. You're preparing to make it permanent, but hey, you can still back out if you need to. Step 2 is git commit. This is the wedding phase. You are officially locking that code into your permanent historical record. You even leave a commit message, like adding a new login button, which is essentially your legally binding signature. And this brilliant little sequence creates a complete journey for your code. You write the code locally on your laptop. You use git add to get engaged. You use git commit to get married and lock it into your local history. But remember, at this point, it's still only sitting on your laptop. To get it up onto that public GitHub portfolio for everyone to see, you use one final command. Git push origin main. That literally pushes your locked-in code straight up to the cloud.
But wait, what happens when you aren't working alone? Let's talk about collaboration without the chaos.
Out in the real world, you are almost never going to be coding totally solo. The secret sauce to team collaboration is something called branches. Imagine your main project is the trunk of a big oak tree. If every single developer tries to work on that same trunk at the exact same time, it is going to be a chaotic mess. Things will break. Instead, Git lets you branch off. The front-end team creates their own independent tree limb to build user interfaces. The back-end team creates a totally separate branch for databases. Everyone works simultaneously, safely isolated, building out their specific features without stepping on each other's toes.
Then, once you finish your amazing new feature on your isolated branch, you obviously need to get it back onto the main project trunk. You do this over on GitHub by creating what's known as a pull request, or a PR. A PR is exactly what it sounds like. You are very politely requesting that your new code be pulled and merged into the pristine main codebase. This is a crucial step because it gives senior developers a chance to review your work, leave a few comments, and make sure everything is absolutely perfect before they hit that final merge button.
Okay, but we all know things don't always go perfectly. Let's talk about what happens when code collides.
Picture this scenario. Developer A is working away on their branch, and they change line 10 to say, create a blue button. Meanwhile, developer B is on their branch, and they change the exact same line 10 to say, create a red dropdown. What happens when you try to merge both of those branches? Well, Git will literally pause the operation, throw its hands in the air, and declare a merge conflict. Git is just a machine, right? It has absolutely no idea if the final project is supposed to have a blue button or a red dropdown, so it forces you, the human, to step in and make the decision.
When you see that merge conflict warning, first rule, do not panic. Modern code editors like VS Code are incredibly smart about this. Git will actually insert some pretty strange-looking markers into your code, things like arrows and equal signs, just to highlight exactly where the collision happened. VS Code detects those markers instantly and gives you these really handy clickable buttons right above the text. You literally just click Accept Current Change if you want to keep your code, or Accept Incoming Change to keep their code. You can even click Accept Both Changes if you realize you need both pieces. Once you click your choice, you just save the file, git add, and git commit. Boom! Conflict resolved. It's really that simple. All right, let's move to our final topic. And honestly, this is the superpower everyone wants: the developer's time machine.
So, how do we fix those terrible, gut-wrenching mistakes? Let's say you just modified a bunch of files and you enthusiastically typed git add to stage all of them. But wait, you suddenly realize you accidentally added a file that has a top-secret database password in it. You're in the engagement phase, but you desperately need to call it off. To fix this, you just use git reset followed by the file name. Think of this as a soft undo. It safely moves the file completely out of the staging area back to just being modified. It cancels the engagement, but, and this is key, it doesn't delete a single line of the code you worked so hard to type.
But what if you went all the way? What if you actually committed the mistake? You officially got married to the terrible code. Well, you can use an absolutely magical command, git reset head shift 1. The crucial takeaway here is that this command literally forces Git to rewind history by exactly one step. It takes the entire state of your project, shifts it backward, and forces Git to completely permanently forget that your last commit ever even happened. It is the ultimate get-out-of-jail-free card.
And this brings us right to the core philosophy of this entire explainer. When you are first learning to code, the fear of breaking things really holds you back. But as long as you are using Git, you have an invincible safety net. No mistake, no accidentally deleted file, and no completely broken feature is ever truly permanent. You can always go back to a working version.
So you now understand the bank account of your code. You know the engagement and wedding phases of saving your work, and you know how to use branches and time machines to collaborate effortlessly without the fear of messing up. So now that you are armed with the ultimate developer survival tool, what incredible project are you going to build and push to your public GitHub portfolio today? Get out there, start coding with confidence, and we will see you in the next explainer.